Good morning, grade 11. Today, inshallah, we're going to start in the first section of chapter 7. In that section, we're going to how to write the chemical formula of different chemical compounds and how to name the chemical compounds also. So let's remember some things that we studied before. Okay, first of all, we need to remember what is a chemical formula. Yes, chemical formula just represent the kind of atoms and how many atoms are involved in the compound. So chemical formula indicates the relative number of atoms of each kind and in a chemical compound. That means what are these atoms, what are the elements involved in this compound, and how much they are. So here, in case of molecular compounds, that means the compounds which already their atoms are bonded by covalent bond, the chemical formula reveals the number of atoms of each element and which found in each molecule. For example, here the octane, of course, is a covalent compound or molecular compound. We count C8H18, so C8H18. So here we have two subscripts, subscript 8 that represent the number of carbons which involved in that molecule, and the 18 here that the subscript describe how many atoms of hydrogen in that molecule. So we could easily observe that we have 8 carbons are bonded to 18 hydrogen bicovalent bonds. Okay, so here like this from that formula we could know what the kind of atoms are involved in this compound and how much of each element or how much atom of each element is found in that molecule. But on the other hand, for the ionic compound or the ionic formula, we said that in ionic compound the formula represents the ratio. It doesn't represent a molecule because we said that the word molecule just describes the covalent bond. But here in case of ionic bond we said the formula unit. Formula unit, it means it describes the simplest ratio that form the crystal lattice of ionic compound. So here it represents the ratio between cations and anions. For example, Al2SO4 by 3, we call them aluminum sulfate. So what actually here we could find that we have subscript 2 and subscript 4 and subscript 3. So subscript 2 describe that in this formula or in that compound we have two aluminum atoms that combine with three polyatomic ions of sulfate. That means the three belongs to all the polyatomic ion. That's why we put it inside brackets. Here, as we find that sulfur doesn't have a subscript, which means we have one sulfur atom in each polyatomic ion, while four oxygen atom in each polyatomic ion. But as we have three polyatomic ions of sulfate, it means we have three sulfurs and 12 oxygen. That means the three is going to be distributed for both sulfur and oxygen. So here we said that we're going to find that represent the ratio. How? So here we see that parentheses surrounded the polyatomic ion. This one we put parentheses. Okay, that means the three. Okay, here to identify it as a unit. Okay, sorry, parentheses, the brackets. Okay, that's here represented. They are just one unit. We put them inside the bracket to refer that the subscript 3 belong to the entire unit, not just for oxygen or sulfur alone. And here, as we said, because there is no subscript under sulfur, it means there is a number 1. But of course, number 1 is not written. Okay, so here we said that first thing, how to write the chemical formula. Okay, how to write formula of monatomic ions. Monatomic ion, that means just single ion. Okay, whatever, positive or negative. So we said that we know that some elements, okay, in different groups of the periodic table, they tend to lose or gain electrons to fill their outer energy level to look like a noble gas. So here we said that with the once the atom loses an electron, it's gonna be cation. Once it does gain an electron, it will be a 9. So here in that case, we were gonna find, for example, nitrogen. Okay, it loses 3 electrons in that way, so it gains 3 electrons to completely fill its outermost energy level. Okay, so here we could find, for example, some other elements in the periodic table. They don't lose or gain, but they prefer to share electrons to complete their outer energy level, like silicon and carbon. So here, let's see how to name the monoatomic ions. So for example, in the cation, we have K positive. That's K is 19, which means it has an outermost energy level 4s1. So in the 4s1, easily during the chemical reaction, losing this electron turning to be a positive ion. So we got potassium cation. Okay, Mg12, it has 2 electrons and 3s. So these 2 electrons are easily lost during the chemical reaction, and in that case, it will be called magnesium cation, and so on. So for monatomic ion, the ending of the element's name is dropped. Okay, that means here we just say magnesium. Okay, and the ending will, in the case of sorry of an ion, that in cation we just mention the name of the element and add cation after it or we could say positive magnesium ion, positive potassium ion, like this. But prefer to say potassium cation or magnesium cation. That's in case of the positive ion. But in the other hand, in anions or the negative ions, we are gonna find that we just drop the last part of the name or the end of the name, and we add the suffix ide or ide. For example, here, okay, we find that's fluorine, fluorine F9. It means it has about 7 electrons in the outermost energy level, so it needs to gain 1 electron to completely fill its outermost energy level. So in that case, we call it fluoride. Instead fluorine, we removed the in, okay, and we add ide. So here fluorine will be fluoride, nitrogen will be nitride, and so on. So this table represents you the different elements and their, okay, valency, how much electrons lost or gained. Okay, so the first column here represent, okay, positive one. That means all these elements already during chemical reaction they lose 1 electron and turn into monopositive or one positive ionic cation. Here they lose 2 and turn to positive cation. Okay, positive 2, that means they lost 2 electrons during chemical reaction, and here they lose 3. This table represents the anions, which they gain electrons. So fluorine, chlorine, bromine, and iodine, all of them, they gain 1 electron during the chemical reaction. Oxygen and sulfate or sulfur, they gain 2 electrons during chemical reaction. Nitrogen and phosphate, they gain 3. So how they represent you to the name? So in case of positive ions, the name is still the same. We just add cation after the name. While in case of anions, we just remove the end and we add IDE. Okay, so should we memorize that table? Of course, you should memorize it. But if you don't want to memorize, so you can use the periodic table and make the electron configuration and predict how much electron will be lost or gained during the chemical reaction. So you could predict the valency of an element from its electron configuration. Here that represents the deep block. Okay, so in that case, deep block, here we have something. Deep block represent, most of them they represent metal, so all of them they are positive ions. But here the most tricky part about deep block elements, that some elements in the deep block they have more than one valency. For example, here we could find that iron could be 2, that means lose 2 during chemical reaction, or 3. So once we write the chemical formula to determine what kind of ion is it, okay, or which kind is it, 2 or 3. So we use some Roman numbers to represent the difference here, as we can see. Vanadium also could be 2 or 3. Okay, chromium the same. Okay, so here these Roman numbers, okay, represent what the kind of atom, how many electrons are lost. Okay, so it's very important to indicate this. So we, in normal cases or normal situation, most deep block elements they are divalent. That means they lose 2 electrons during the chemical reaction. But in some situations they may lose 3 or even 4. So we could know that depends on the Roman number which wrote beside the name of the ion. So here, like this, then guys, we've said that by binary ionic compounds, let's start to know how we could write the chemical formula once 2 ions are gonna combine. So compounds composed of 2 elements are known as binary compounds. So in binary ionic compound, the total number of positive charge that are lost must equal the total number of charge that are gained. That means here, if we have one atom that lose 2 electrons and another atom that gain 1 electron, so it means this atom which lose 2 electrons must combine with 2 atoms which each one gain 1. So like this, we keep the number of electrons which lost and gained are equal. So the formula for binary ionic compound can be written given identities of the compound ion. Example, magnesium bromide. So how we could write magnesium bromide, or what is the technique to do? So we have actually 2 techniques. We're gonna use the simplest one here. So let's see how we're gonna do it. Okay. So he said that magnesium bromide. So magnesium bromide. So first step, we write the name of the chemical compound. Then magnesium, the symbol of magnesium is Mg. Bromide is Pr. The valence of magnesium is 2. Of course, positive. Always we start by positive side, and that's always the negative side. Okay. So here magnesium is 2. So like that, its valence equal to, while bromine, okay, is 1. Then we switch, okay, the valences, which means magnesium, okay, well, just 1. We don't write number 1 because it's by default, okay, just 1 atom magnesium, and Pr2. So like that, that magnesium bromide. So why 1 magnesium is combined with 2 bromine? Because as you can see here, magnesium during chemical reaction lose 2 electrons, while each bromine atom just gain 1 electron. So in that case, once magnesium loses 2, it requires to bond with 2 bromine to because each one will gonna receive one electron. So like this, the number of electrons lost by magnesium equal to the number of electrons which gained by bromine. So that's the way we could use, okay, to write the chemical formula, okay, of some. Let's take more practice here, guys. So here, let's take for this, for example, aluminum oxide, okay. So aluminum oxide, aluminum is a, sorry guys. So aluminum oxide, that's aluminum oxide is O. So the valence of aluminum, okay, if you factor the electron configuration, you're gonna find that aluminum have 3 electrons in the outermost energy level, so they easily be lost during the chemical reaction, so its valence equal 3. While oxygen, it has 6 electrons in the outermost energy level, so it should gain 2 to fill its outermost energy level, so that means its valence equal 2. So in that case, we're gonna exchange, okay, the valencies. So in that case, we're gonna find Al2O3. Okay, so that's here the aluminum oxide, which means each 2 atoms of aluminum must be bonded with 3 oxygen atoms. Okay, so we're gonna find that's here. So overall, we're gonna find that the simple as we did, Al2O3. So we're right here. So like this, guys, we know how to write the chemical formula of a binary compound. So here in the nomenclature, how we are gonna naming, okay, or how we could name that, okay, or the binary ion. So simply as we used, okay, for example, Al2O3. So the first part is the cation, aluminum. So take the same name, aluminum, because we know that cation we don't change the name. So we say aluminum, while the other part, the amine, instead of saying oxygen, we're gonna replace the last part with the prefix IDE. So it will be aluminum oxide, okay. So here, let's see, for example, write the formula for the binary ionic compounds formed between the following elements, okay, zinc and iodine, zinc and sulfur, okay. So zinc is gonna be, let's try to do this, guys. So zinc and iodine. So zinc is Zn, iodine I. So the valence of zinc, that okay, the default valence of zinc is 2, while iodine is 1. So once we switch places, it will be Zni. Okay, so what the name of that compound? Okay, or what we call this? It will be zinc iodide. Okay, so that's how to write the formula. Okay, and also how to name it. Okay, then zinc and sulfur. So zinc is Z and sulfur is S. Okay, zinc valence is 2, sulfur is 4. Okay, so once we switch places, okay, so we're gonna find in that case, okay, so it will be, sorry, sulfur also, yep, okay, so it will be Z and for S2, then we simplifying, so we're gonna find it will be Z and 2S, okay, so we call this zinc sulfide, okay. So that's how, guys, okay, we could write the chemical formula of some elements, okay. So here, this is the point, okay. We know how to do it, okay. So how we know how to write the chemical formula, and also we know how to name the compound. So I think it's easy, guys, okay. So please practice this here, and before let's find, okay, our answers, okay. So that's our part for, or that's the part which we're going to stop at. And next time, inshallah, we're going to continue the lesson. We're going to pass to the covalent compounds, how to name and write the chemical formula of covalent compounds. So please study this part well for your home. And if you have any question, please ask. Thank you, guys, and goodbye.